So in exercise 61, we have to sketch the slope field for the differential equation given, then use the slope field to sketch the solution that goes through the point 4, 2, and then discuss the graph of the solution as x approaches infinity and negative infinity. So, we have the differential equation y prime equals 3 minus x. So if we want to sketch the slope field, the slope field is a series of ticks that we're going to draw for every unit. So we're going to draw them at all of these points first to see what happens. Here's how we're gonna read that. The slope is 3 minus the x value or the x coordinate of the point. So every time x is 0 for all the points along the y-axis, the slope is 3 minus 0. So the slope is 3. If you want to sketch that carefully, you could say, okay, so here I go 1 to the right, 3 up. That's what my slope should look like. And the tick is going to be like this. They're parallel everywhere. For all of these points, x equals 1. So the slope is going to be the same in this case. Y prime is 3 minus 1, so y prime equals 2. So from here, it's going to point towards this in order to get a slope of 2, kind of, and then they're all parallel. And now we already kind of see a pattern. It's convenient to work on these vertically. If x equals 2, like here, the point 2, 0, the point 2, 1, the point 2, 2, then the slope is 3 minus 2 equals 1. So from here, a slope of 1 goes there. It's 45 degrees, like this, like this. It doesn't really matter if you're perfect when you sketch these slope field, but it does matter that slopes look steeper. A slope of 2, it doesn't matter if it's exactly 2, but it should look steeper than a slope of 1. Now when x equals 3, for all these points here, the slope is going to be equal to 0. So that. Because we have to sketch the solution through the point 4, 2, 1, 2, 3, 4, 1, 2 here, I'm gonna go further and find the slopes at these points. When x equals 4, the slope is negative 1. So it's going down 45 degrees. If we wanted to draw more, we could, following the same pattern. Make sure when you do that you always recognize that it makes sense, that there's no tick that goes in a weird way suddenly. It's not rare for me to see in exams something like that. When you see that, you should notice, wow, I probably made a mistake here. This tick is probably not suddenly going in a different direction than all the others. There's got to be some kind of flow most of the time. So that's question A. Now question B is to sketch the solution through 4, 2, 1, 2, 3, 4, 1, 2. And we need to do as well as we can, following the ticks, following the flow. Might be something like this. It doesn't have to go on the ticks here. I'm assuming it should, because it seems like it's symmetrical, so it should go over the tick. But here, probably not. It's not going to go perfectly on ticks. But if it's between ticks, then the slope should be a slope that's between the ticks it's passing. Okay, by the way, this is the equation of a line, so we could integrate and find that it's 3x minus 1/2 x squared plus c, and we could find the value of c by substituting 4 and 2. But my point is, this is clearly a parabola, which explains the shape here. So question C, as x approaches positive infinity, f of x approaches So now we're talking about the solution. So as x goes to positive infinity, f of x is just going to drop down, down, down. Likewise, as x approaches negative infinity, I'm going this way, f of x approaches negative infinity. So just a quick summary. When you are discussing a differential equation, you are going to have some kind of y prime when you write the expression. It includes some y primes. And visually, it's going to be a slope field. When you talk about the solution of a differential equation, it's going to be y equals. It's going to be a function. And it's going to be just the graph of a function. Okay, so a differential equation includes some y prime in its expression, and it's represented by a slope field. The solution to a differential equation is a function, so it's y equals, and it has a graph. It's almost like this is like these very small kids' game where they have a block which has holes of different shapes. That would be your differential equation, and then the small cubes that you can fit in if you choose the right cube with the same shape as the hole. That would be your solution. So there's different solutions depending on where you choose to place it. Just like in these kids' game, you can find different shapes provided you put it in the right hole, it's going to go in the box. The next exercise we're going to go over together is this one. We have a slope field. It's the slope field for y prime equals 1 over x, and we have to sketch the solution that satisfies the given initial conditions. The given initial conditions are here. It's going through the point 1, 0, and it's going through the point 2, negative 1. Two different solutions, one for this, one for that. And then we have to write again the end behavior. What happens when x approaches positive infinity? So here's the graph of the differential equation. Here's the slope field. It's pretty easy. That's the point 1, 0. I want to sketch the solution, so sketch the function that fits nicely along these ticks. Maybe something like that, something like that. So it's important to make sure that you're not crossing these ticks. If I'm passing by a tick, I should be nicely aligned with it. So for 2, negative 1, this is the point. Therefore, the solution is something maybe like that. Where I cross the x-axis is a little unclear. We can't, this is just a sketch, it's an approximation, so I'm not exactly sure where it is exactly, but that would be the solution. By the way, we were told that y prime equals 1 over x, so we actually know what the solutions look like. The solutions are graphs of logs, and this one is just another solution with a different value of c. So it's parallel to that, it's just been shifted down by a certain amount, and in order to find c, I could just plug in x equals 2, y equals negative 1 to figure out the value of c. Oh, and there's also, we need to say as x approaches infinity, what happens to the solution? It may look like it's kind of stopping, there's like a horizontal asymptote somewhere, but given that we know that the solution is y equals ln of x plus c, we know these graphs of ln of x just keep on going up extremely slowly, but there's no horizontal asymptote, so f of x approaches positive infinity. Finally, we'll work backwards a little bit in this exercise. This time we are given the graph of a solution and we are trying to find the differential equation that would fit this solution. So if I go back to the image with the kids' boxes, this time we are given a small cube and we have to find a box which contains the hole that the small cube is going to go in. So here, which one of these is going to give me a slope field where that matches nicely? So we're not going to sketch all these slope fields, we're going to be more clever than that, but definitely the ticks along here, we can't even see them, because if there's ticks along the graph, then the graph should follow them. So maybe I'm just going to make up ticks elsewhere. We may assume that the slope field looks something like that. As we know, it always kind of has a flow. So maybe the slope field is made up of ticks like that, and who knows what happens below. But actually, it doesn't really matter. If we want to find out which of these four options matches this solution, one great way to start is to look at this point here, because this point up here has a special slope. The slope is 0. So we should find y prime equals 0 when x equals 0. We actually don't know what the value of y is, but we definitely know that y prime equals 0 when x equals 0. So does it work? If x equals 0, yes, y prime equals 0. If x equals 0, yes, y prime equals 0. If x equals 0, yes, y prime equals 0. If x equals 0, this time, if x equals 0, y prime equals 4. So we can remove this solution. Now, what else can we look for? We could look at here. It looks like when x approaches infinity, the derivative y prime approaches 0. That's interesting. Let's look at what happens. Here it seems like when x approaches infinity, this is going to get bigger and bigger. When x approaches infinity here, it seems like this is going to get bigger and bigger as well. And if x approaches infinity, this is going to be bigger and bigger in the negative values. So that's weird. It doesn't seem to work. How can we explain that? Well, it actually took me a moment to figure it out, but this time the value of y is really important. Y is so close to 0 here that even though x is large, y is minuscule, and maybe this is not getting bigger and bigger. Who knows? So we need to find something else than that idea. And the idea we want to work on is thinking about quadrant 1 in general. In quadrant 1, we have positive values of x, we have positive values of y. All these points in here are such that x and y are positive. And look at the slope. Y prime is negative everywhere. So maybe this is going to be a key element that's going to help us figure out which one of ABC is correct. If x and y are both positive, this is definitely going to give us a positive number. So it doesn't work because I can see the slope is negative. Here, if x is positive and y is positive, this is going to be a positive number, so that cannot be. Finally, if x is positive and y is positive, I'm going to have y prime equals negative something, so that is the correct answer.